Alright, so this is global warming. It's fairly simple, but just thought putting in a video might help a few people out. So let's say we've got our Earth there, and here's me on the Earth, and here is the atmosphere around the Earth, and here is Mr. Sun. He's a happy little chap. And basically, what should happen is heat, I say heat, any type of electromagnetic radiation, so UV, infrared, light, gamma, all the different type of radiation from the sun will hit the atmosphere, and a little bit will get deflected, but most of it will go straight through and hit the Earth. And again, a little bit will get shot back into space, but most of it will actually get absorbed by the Earth, and what it'll do is it'll heat the Earth's surface up. Okay, so that'll heat the Earth's surface. Later on, what will happen is the Earth will radiate that heat back out. Just like when you take a metal tin out of the oven, it gets hotter, you take it out, it radiates the heat back out to cool down. And this heat will go out through the atmosphere into outer space, and the Earth cools down again. That's what should happen. But now what we've got is loads of greenhouse gases in the atmosphere, namely H2O, water, CO2 and CH4, so carbon dioxide and methane. And basically what they do is they can absorb the infrared radiation being given out by the Earth, because heat energy is just infrared radiation, they're one and the same. Yeah. So usually the infrared radiation goes straight through the atmosphere. Now, as it goes through the atmosphere, it gets absorbed by mainly these three gases. And what those three gases do is they absorb it to make their bonds vibrate more. So usually they kind of go like this, zap it with some infrared radiation, and they vibrate loads more. After a bit of time, they'll slow down and give that infrared radiation back out. But not only do they give it back out into outer space, sometimes they'll give it back out back down to Earth. Basically they scatter it. So overall, what happens is greenhouse gases give these infrared radiation rays back down to Earth. They force them back down. And of course, more infrared radiation means more heat means a hotter Earth, ice caps melt, we're all in trouble, basically. A little thing on that as well, on the North Pole and the South Pole, I think as well, there's things called clathrate deposits, which are massive patches of ice filled with CO2 gas. So as the Earth gets hotter and the ice caps melt, it releases this CO2 into the atmosphere. CO2 is a greenhouse gas. So because it's releasing greenhouse gas, it gets hotter, more ice melts. Releases more CO2, gets hotter, more ice melts. It's just like a vicious cycle. So just one thing to be aware of is that clathrate deposits could make it a lot hotter around here. So these are our three gases, and what I said is they absorb radiation, and the specific bonds which do that are as follows. In water, it's your OH bond. So the radiation, infrared radiation, hits the bond, gets absorbed, makes it wiggle and vibrate faster, and then eventually will get given out in a random direction. Could be up, but more importantly, it could be down. We've also got our C-double-O bond, don't forget that's a double bond, on our carbon dioxide, and our CH bond on our methane. It's dead easy to remember because they're the only bonds you get in each of these three things. Now water is the most common greenhouse gas. There's loads of water vapour in the atmosphere, but it's not that good at absorbing infrared radiation, so it's not too much of a problem. This is the kind of the medium concentration and the medium goodness at absorbing radiation. There's not much CH4 in the atmosphere compared to these two, but this is like the McDaddy absorbing infrared radiation. It does it really easily, so this is a very potent greenhouse gas. We say it's got a very high global warming potential, or GWP. Okay, so they absorb it. What can we do about this? Well, we've come up with some really awesome ideas in order to reduce these gases in the atmosphere. One of them is to, obviously we get this mainly from the evaporation of oceans, so what we're going to do is put a massive string of cling film over all the oceans. Obviously that's not what we're going to do. There's nothing we can do about that. Okay? This mostly comes from decaying organic matter, so unless we find kind of the elixir of life, we're not going to be able to do much about that either. This one, however, we can reduce. Okay? And there's two kind of really interesting and kind of thoughtful ways we've invented to do this. One of them is dead simple. You've probably seen the reaction before where we take calcium oxide and we react it with carbon dioxide gas, and that will make calcium carbonate, limestone. So essentially what we've done, if we trap our CO2 and force it to react with calcium oxide, or for example magnesium oxide, we will get a metal carbonate. So we've trapped the carbon dioxide, and that's one way we can do it. And that's really good because not only does it help us because it stops global warming, but the people who do this can then sell that limestone, so they kind of everyone's quids in. Another thing we can do, here's my oil station, here's my oil deposit under the sea, and usually what happens is we pump the oil out, we send it to the electricity station where it's burnt to make electricity, and all the carbon dioxide gas gets released into the atmosphere. What we've started to do now is we trap the carbon dioxide gas and we send it back into this underground cavern, this oil well. So as the oil is removed, we're adding the carbon dioxide back. And that's really good because this rock is naturally non-porous, otherwise the oil won't be there in the first place. So it can't escape. It's going to be there for at least, a good 100,000 years or definitely more. So it's not going to be released anytime soon. It's cost effective, we don't need to build a hole, it's already there. And adding the carbon dioxide gas causes the oil at the bottom to be obtained easier. So it is good for the oil companies, which is probably why they do it, because it means they can get more oil out of it. So everyone's a winner. And that is global warming.